AP Calculus, section 4.2, page 2. We are going to start off today by graphing f of x is 1 minus x quantity squared times 1 plus x quantity cubed on your calculator, and identify the relative extrema and the intervals where f of x is increasing and where it is decreasing. I've already entered that onto the calculator and changed the window. My window is set from -5 to 5 in the x's, -5 to 5 in the y's. And here's that graph. This is what we see. If we sketch this onto paper, we have something like this. And we want to find intervals where this function is increasing and where it's decreasing. Identify the relative extrema. So looking at this graph, I'm going to use the one on paper. We see a relative maximum point here and a relative minimum here. And if we check those, we are going to have a relative maximum at x is 0.2, y is 1.105. So right here, this max is at 0.2, comma, 1.105, 1.106. And looking at this point down here, there we see a relative minimum. If we run through minimum there, and we get x is 0.999999837. Oh my, that's x is 1. And look at this, 2.114 e to the negative 11. That's 2.114 times 10 to the negative 11th. That's 0 for all practical purposes here. So this point is at 1, 0. When we look at this then, we see that we have a relative max equal to 1.106 at x equals 0.2. We see a relative minimum equal to 0 at x equals 1. And then let's identify increasing and decreasing. Let's see, we see this function increase all the way up to 0.2. So increases from negative infinity up to 0.2, and also increasing again from 1 to infinity. And this function decreases from 0.2 up to 1. Alright, now that's reading off the calculator. Let's go ahead and verify our answers to that problem analytically, which means we need to look at the derivative and when the derivative is positive and when the derivative is negative. Let's find the derivative here, f prime. Oh man, we have a product rule and a chain rule here. So let's start first. That's 1 minus x to the second times the derivative of the second, so 3 times the 1 plus x quantity squared times the derivative of the inside, which would be 1, plus, now second, 1 plus x cubed times the derivative of the first, 1 minus x, oops, Need that 2 coming down. 2 times the 1 minus x to the first times the derivative of the inside, which is a negative 1. Cleaning this up a bit, we see 3 times the 1 minus x quantity squared times the 1 plus x quantity squared. Over here, minus 2 times a 1 minus x to the first and a 1 plus x cubed. Let's go ahead and factor that. I see a 1 minus x common and a 1 plus x to the second. From this first part, we need a 3 and a 1 minus x. From the second part, we'll need a minus 2 and a 1 plus x. Simplifying inside these square brackets, that's 3 minus 3x minus 2 minus 2x. And we have 3 minus a 2, that's 1 minus 5x. Everything's factored, that's as far as we can go. Once we're here, then we need to look for where f prime can equal 0, where f prime of x is undefined, and where f prime of x does not exist. Nice polynomial here for our derivative, so there aren't any non-existent values or undefined values for the derivative. F prime equal to 0 can happen here at 1, at negative 1, and at 1/5. All right, once we have those values then, these critical numbers, we are going to go ahead and create a chart, a superchart. We did this a while ago when we were doing rectilinear motion. Do you remember the particle moving back and forth along a horizontal or vertical line? Okay, so we have some columns here. We have an x column, an f of x column, an f prime column, and a description of f of x. We're going to use these values here to kind of divide up this interval in here. And their smallest critical number is -1. So we'll start at x less than -1. Then we'll look at x equals -1. The next critical number is 1/5. So we'll look between -1 and 1/5, at 1/5, between 1/5 and 1, at x equals 1, and also x greater than 1. I like to put some horizontal lines in here to help keep my chart organized. All right, here we go. Now, f prime. We know that f prime is equal to 0 at these three numbers. So we can fill that in. When x is -1, f prime is 0. When x is 1/5, f prime was 0. And x is 1, f prime 0. Now we do a sign analysis. So let's look when x is less than -1. And in this quantity right here, we're going to substitute back in. We're just interested in a sign of f prime of x. Something smaller than -1, perhaps -2. Plug a -2 in here, and this quantity is positive. This quantity I don't need to check because that sign will always be positive because that's square. And then put a negative 2 in here. 1 minus 5 times a negative 2. That's positive. So we have positive times positive. Overall positive. A number in between negative 1 and 1/5. How about a 0? This quantity would be positive. Remember, I don't need to check this one. And this quantity is also positive. So we have another positive here. And how about this one? From something in between 1/5 and 1. How about a half? 1 minus a half, that's positive. Over here, 1 minus 5 times a half. 5 times a half is 2.5. So 1 minus 2.5, that's negative. A positive times a negative, negative. And then when x is greater than 1, say 2. 1 minus 2, that's negative. 1 minus 10, that's negative. So overall positive. All right, now for the description. If f prime of x is positive, then f of x is increasing. If f prime of x is positive, then f of x is increasing. Decreasing, f prime negative, means f of x is decreasing. And f prime positive means f of x is increasing. All right, what about all these ones I missed? Well, if f prime of x is 0, then f of x has a horizontal tangent. F prime of x is equal to 0. We have another horizontal tangent on f of x. All right, now think with me for a minute. I'm going to kind of bounce around here, changing from right here. We are decreasing on f of x, changing to a horizontal tangent, and then increasing. A function that decreases, flattens out, and then increases. That's a relative minimum. And right here, a function changing from increasing to decreasing at a horizontal tangent. So that function is increasing. It flattens out to a horizontal tangent and then decreases. Increasing, flatten out, decreasing. That's a relative max. And right here, this function is increasing, changing to a horizontal tangent, still increasing. Increasing, flattening out, increasing. There is no extreme value here. Just a horizontal tangent. Okay, now looking at our chart, when we read this, for our graph to be, when we want to know about when is this function increasing, decreasing, extreme values, we can see right here, there is a relative max equal to, I gotta find the y values. So I would take these nice points and plug those y values back into the original function. At -1, that function is 0. At 1/5, we already know it up here. It's from this chart. We already got it. So I'm going to save us some time here rather than just plugging back in. That's 1.106, and at x equals 1, 0. If you didn't have the graph already, well then absolutely you would take 1/5 and plug it back into the original function. We still see a relative maximum of 1.106 at x equals 1/5. A relative minimum equal to 0 at x equals 1. So y value, that's the relative minimum at x equals 1. And increasing increasing from negative infinity to negative 1, from negative 1 up to 1/5. Yeah, and then increasing again from 1 up to infinity, decreasing on 1/5 up to 1. Okay, there's a discrepancy here between this chart that we did right here and the increasing that we came with up over here. This one only had 2 intervals. It went from negative infinity all the way up to 0.2 and then 1 to infinity. This one we split it right here at negative 1. And when this happens, you kind of need to think about this. It really does increase, this function does increase from negative infinity all the way up to 1/5. And you have to think about that. If we kind of look at the graph, it does flatten out here momentarily, but if we think back to what increasing says, if the y value, as you move along, if the y value gets bigger, the x values get bigger, then that function is increasing. So we are increasing, or f of x does increase over that point right there at that -1, so we can combine that together. Oops, combine this together. Thanks for tuning in to page 2. I know this was a long one. Thanks.